Good afternoon, ladies and gentlemen. My name is Jordanai Sukasem. I am an archaeologist from the Fine Art Department, Thailand. Today, I will present about experimental archaeology and assumption about the product from prehistoric ancient iron smelting site of northern Thailand. This presentation consists of three main issues. First, to present the ancient iron smelting site from archaeological study in Lee Basin, northern Thailand. Second, to present the latest findings from archaeological evidence on ancient iron smelting technology. Last, to present the findings from the synthesis of knowledge through experimental archaeology. Chapter 1, I will to present the ancient iron smelting site from archaeological study in Lee Basin, northern Thailand. The study area, Lee Basin, is located in the northern of Thailand, which is a part of mainland Southeast Asia, currently surrounded by countries such as Myanmar and Laos. The archaeological survey over the past 5 years, we found 50 ancient metallurgy sites, include ancient iron smelting site, ancient iron mining site, ancient ore dressing site, and iron ore vein. The most significant evidence which we found in this survey is the smelting furnace. Luckily, the furnace is in good condition. We can equate to study its structure. In 2018 to 2019, we have excavation project. Following the picture, we have more excavating and keep some artifacts to analyze in laboratory with scientific method. We found some interesting archaeological evidence. This is two in situ iron furnace structure, which was found in San Hui Tokin number 1 site. The soil profile represents the smelting activity is in process in short time. The smelting layer is only 30 cm deep. Let me show you an in situ shaft furnace. The diameter is 90 cm on the furnace wall has a boring hole which has exit being tilted at 30 to 45 degrees. On the bottom of furnace has 4 select tap holes. According to the Hendon XRF analysis result, the smelting temperature of both sides is about 1150 to 1300 Celsius degree. The smelting technique is direct process. The type of furnace is shaft furnace made from purely clay. The diameter is 70 to 90 cm and 150 to 180 cm high. It has boring holes surround on the middle of furnace body and 4 select tap holes on the bottom of furnace. This is AMS dating from charcoal, which was found inside select from Lee Basin is 500 to 200 before Christ. So the dating indicated that the group of iron smelting sites in Lee Basin, northern Thailand is the oldest iron smelting site in Thailand nowadays. This iron smelting site is the early iron age of Thailand and Southeast Asia. Next, chapter 2, let's talk about the latest findings from archaeological evidence on ancient iron smelting technology. As mentioned in the beginning archaeological excavation, we discovered a remarkable ancient iron smelting furnace. It is in situ shaft furnace. The diameter is 90 cm. On the furnace wall has an boring hole which has exit being tilted at 30 to 45 degrees. The archaeologists assume this boring hole is show the intention of causing a whirlwind in the smelting furnace. To verify the assumption, archaeologist team has studied the internal structure of furnace until we discovered that inside the furnace, slag was found along the edge of furnace wall, shaped like circle. Why we found nothing in the middle area of the sheet? So we assume that the blowing holes are likely to generate high heat only around the inner edge of smelting furnace, and the high heat may not reach the center of the smelting furnace. The discovery led to the next two questions. How does the whirlwind result in the iron smelting process? And what is shape of iron room after the whirlwind process? Next, chapter 3, let's talk about finding from the synthesis of knowledge through experimental archaeology. This is a question archaeologist team and the expert in iron smelting work together to simulate the ancient technology again. There are two purposes of this study. First, to simulate a pattern and ancient technologies that related to iron smelting 2000 years ago, which will lead to knowledge and understanding about archaeological records. Second, to make an assumption about the shape of product that we obtain from the ancient iron smelting site in Lee Basin, northern Thailand. The question of this study starts from the discovery of iron smelting furnace still in situ by making a blowing hole cone-shaped diagonally to the wall of the furnace 30 to 45 degrees, show the intention of causing a whirlwind in the smelting furnace. From this cover, what were the factors that resulted in the ancient iron smelting process? To prepare this simulation, we try to choose the materials that are similar as much as possible to those found in archaeological sites. We prepared three materials. First is soil. We took soil from the area nearby the ancient iron smelting site in Lee District, Lamphun Province. Second is charcoal. We used a variety of charcoal which found in Lee District, Lamphun Province. The third is iron ore. In this smelting, we use magnetite iron ore is bought from vein which found in archaeological site. In the process of soil preparation, we use soil which taken from the area nearby the archaeological site. It is sandy clay which has been fermented with water for 3 days. We also kiss the soil 3 times to make the soil finer and more condensed. Next step is from smelting furnace. We try to create the same model as much as possible with the ancient assumption from. Clay are used for making the smelting furnace structure. The width of the furnace base is 100 cm. The height is 140 cm. The furnace mouth is 80 cm wide, and the thickness of furnace wall is 20 cm. Next, making blowing hole. The team has drilled and blowing hole 20 cm higher from the base of the furnace and drilled into a cone-shaped hole. At the angle of 30 degrees to the furnace wall, a total of 16 channels are arranged around the furnace. At the bottom of the furnace, square holes are drilled in the 4 directions. The next step is providing heating to furnace. The team used firewood to build up temperature inside the smelting furnace to make the soil dry and ready enough for the smelting process. Next, we start the smelting process by adding charcoal until the furnace is full, and fill the air through all 16 blowing holes, which carry creates swirling air in the furnace. After that, the ore was added alternately with the fuel charcoal. The time interval is 5 to 10 minutes, mainly observing the combustion characteristic and keep record. This picture is charcoal filling process, which is subdivided into diameter of 3 to 5 centimeters. The next picture is process adding iron ore, which was subdivided into a size of 2 to 4 centimeters, similar to evidence we found in archaeological sites. Next is to drain the slag out during the smelting process. Through the aeration chamber, the team observed the condition occurring inside the blast furnace. When it was found that there is a high level of slag accumulation, we will drill through the hole at the base of the furnace in all four directions. Next, we took the iron ingot product from the furnace after 4.5 hours. The research team found that iron bloom and has accumulated and clogged the aerator. Then we finished the smelting process and mixing the furnace to bring out the ingot of iron. Finally, the productivity from this iron smelting is 47 kilograms of iron bloom in the special ring shape, which show you now on this slide. If coated with other pieces of iron, the total productivity obtained from this iron smelting is up to 50 kilograms. In this archaeological experiment, we took 100 kilograms of iron ore and 380 kilograms of charcoal were used. This experiment generated enhancing knowledge and understanding as follows. First, the issue of research utilization and productivity. In this smelting, 100 kilograms of magnetite iron ore is used, yielding 50 kilograms of iron bloom. The cost ratio is 1 to 2 or half, which is considered a higher proportion of productivity than iron smelting by traditional method in general. A ratio between production and iron ore cost as 1 to 3. Second, product characteristic issue. The product process of aeration through a blowing hole concave diagonally of 30 degrees creates a spiral air inside the furnace. As a result, the steel will accumulate at high temperature until it forms a lump of iron bloom that has ring shape. From the product appearance, it is therefore preliminary archaeological assumption that the product iron bloom from the ancient iron smelting furnace site in Lee Basin, northern Thailand. Last but not least, succession for further development. As this is a beginning of study of experimental archaeology in archaeometallurgy in Thailand. Therefore, there is still a lack of scientific equipment used to collect insight. On the future, we expect to provide more scientific equipment to support the experimental and for perfect development to knowledge. That is all my presentation today. I sincerely appreciate that I have this opportunity to present to you. Thank you for your interest and attention.